we've been supporting OIPI in what's called the project pipeline. The goal was to execute a lot of studies statewide that really focused on high priority locations. And so when we're trying to execute 45 studies simultaneously across the state, having good data up front that is able to quickly identify needs, help us get through that existing conditions and focus on the real problems is very key. And so state of Virginia has a lot of great crash database sources, INRIX and other items where we were able to create data dashboards that very much help the study teams get going. However, one of the big kind of holes last year during the summer when we were getting the program underway was we didn't have a really great tool to help assess bicycle pedestrian accessibility and as well as transit ridership, some of the latent demand. So Sogan and I kind of worked together to see what we could do, with the StreetLight data that might help us get to some dashboards that would help support the teams in the next go round. So what you see here is kind of our pilot demo effort that we've been working with OIPI on and plan to submit later this fall when we get new study locations to really help support those teams in having good data to really see what the gaps in the network are, where transit routes would be appropriate and very well utilized, and where bicycle facilities could see good demand. So with that, I'll turn it over to Sogan to talk a little bit about the technical side.
So today we have a short presentation on a dashboard that we created, as Nathan mentioned. This is specifically for active transportation, naming pedestrian, cyclists, and transit riders. Very quick on our goals. Pretty much we want to estimate demand for bike fit because often we don't have a good data on it. When we have an estimation, we want to also identify gaps in sidewalk and bike facilities and see how we can accommodate more cycling and walking in any area. Our objectives are improving access to jobs, access to transit, increase connectivity, and enhance equity, emphasis population mobility. So what do we talk about and why we are talking about? So currently a scoring system is not comprehensive for multimodal transportation, and it's focused on auto. System focuses on traditional vehicular measures like level of service, queue length, delay per vehicle, etc. And advantages of revising this scoring system based on a data-driven approach are in the range, are so many, but to name a few: benefit all modes of transportation rather than only auto, bring funding opportunities to accessibility and mobility projects, connect communities that have been divided by highways and all other interstate projects, and reduce equity and environmental injustice in those communities. We set some assumptions for multimodal scoring system, and we kind of adopted from what is accepted in Virginia in V-Trans. We assume that walking is any trips that people are driving, but those trips are shorter than 2 miles. Biking is any trips that people are currently driving, but is less than 5 miles. And transit ridership could be any kind of trips that today people are driving for 45 minutes. However, if they have access within a half a mile to a bus stop, they could take that trip as a transit trip. Why we are doing this data-driven approach? As I said, there is not much data. And what we can do is leveraging a StreetLight InSight analysis with a middle filter. For those who are not familiar, you can just, rather than looking at trips that go from A to B, you can just set that trips that go from A, passing through C and getting to B. This is just the whole idea of middle filter. This way, the information that we're going to have is identifying trip numbers, length, and purpose, and identifying origin and destinations of those trips. And then taking all of this information in GIS analysis and looking at the StreetLight result, we can locate inadequate or missing sidewalks, pet crossings, bike facilities, bus stops, etc., that would be needed for more active transportation. This is very basic general schematic of what we have done as a flow chart. So we identify project area that per year is something between 40 to 50 projects. And then we can look at the first level at what kind of land use is it, residential, industrial, commercial. We can look at the bus stops and transit stations at the current and existing or also like future projects. And then when we identify bus stops, we're gonna create a zone, like a distance from each bus stop for 0.25 mile. And we call it kind of convenient to walk to bus stop. We're gonna run a StreetLight InSight analysis for driving mode because that's what we have today. And then the post analysis for our purpose, which is looking at if trips are less than a mile, we call them walking. If they are less than 7 miles, we label them as biking. And if they are less than 45 minutes, we associate them with a possible transit trip. Here it's one example of what am I talking about, and as like walking, biking, and transit ridership estimate can look like. In the dashboard that we created in Power BI and the user StreetLight data has some very like simple look, and it's easy to use. It's very user friendly. I'm going to show you each mode and how to read it from the dashboard. As you can see, we selected the location based on 2021 project pipeline, which is in Tyson Corner, Northern Virginia. It's a very busy corner. It's very interesting dynamic between having metro transit and constant congestion. So what we looked at is at this like a TAZ around this specific part of the road in Tyson Corner. We looked at the origin destination. The top part in orange shows origins, and the map below in blue shows destinations. Obviously, you can zoom in and you can just kind of examine it when you're in Power BI. This is like just a snapshot of what we have in a dashboard. The dashboard can accommodate as many projects that you want. You can just give every project the ID, and then you can look at different attributes per time of the day and day of a week. And then you can look at all the estimated modes individually. So in this case, we have average daily traffic volume between all the origins and zones about 22K, which is in dark blue from top to bottom. And then from there, you can see that walking, which is trips less than a mile between different origin and destination, is about 9,000 trips that are less than a mile in 24 hours. And then in next slide, I selected bike, and then the light blue chart shows potential biking trips for the area. And these are trips less than 5 miles, and they are 25K trips per day. It's a significant number if you can think of what can be reduced from daily volume and what we invest in widening the roads or put the focus on signal optimization only for cars. So what if these people start walking and biking? So basically you don't need to spend so much money and time to just one mode, which is auto. And then the last one is transit ridership in the area. Basically, we look at trips that taking more than 45 minutes. And generally from my just experience playing with the StreetLight data, they are falling within 7 miles from your zone. You cannot find a trip that is 45 minutes and 20 miles away. So you can just kind of have a rough estimate of how many zones or how far you go to choose your origin destinations. And as you can see, it's like more than 400K trips. So you can get so many information. It depends on your application, but because this dashboard gonna use as the very first level of planning and exploring what is possible in a study area that has safety or operation issues, here I added a few pie charts and bar charts to the dashboard that's showing you trip purpose, home base, other home base work, and non-home base on top left. And then below that is the distribution of the speed. It was really interesting to see that the speed distribution goes significantly toward lower speed, which is 0 to 10 miles per hour. Having all of these highways in this area is another proof for congestion and inefficient mode, which is driving. And then because we know that traveling as a family or individual can have an effect to decide make that trip, per se biking, we also look at how many trips happening with parents with their kids or without kids. The other thing that often contribute to selecting a mode of transportation is race and gender. Here we brought the race. Gender was often 50-50, so we didn't bring it. And then also I brought the travel time distribution in the bar chart. As you can see, again, majority of trips are happening within a short distance. So, and all of these short distance trips are a good target to switch to active transportation. Last but not least, lesson that we learned from using the StreetLight metrics in this project, we are doing, what is very important here for us is that we are doing a scalable analysis for a high number of projects, and we want it to be in an efficient way. It's important to make your ready-to-use template for zones in GIS. We use traffic analysis zones or TAZs. You might use zip code or any other zoning that was efficient for this purpose. You're going to repeat the analysis with the same metrics in a StreetLight and make no changes to the naming, attributes, or nothing, because it will mess up when you take them to Power BI. And then append tables in Power BI that help the efficiency of running the dashboard.